All right, so in our last section, we were looking at factoring equations where you just had an x squared first, there wasn't a number in front of it, which is called a coefficient. Now we're going to look at the situations where we do have a coefficient on our first term, so like the 2 here on this first one, and how we factor that. So it's going to actually start in a similar way. So we're going to draw an x first. Okay, but we're not going to put 5 on the top. Okay, in our last one we were actually doing this, but I didn't mention it. What we're doing to get this top number right here is we're multiplying a times c. Okay, before your a was 1, so when you took your c times 1, it was just whatever the c value was, which is this number right here. Okay, so we multiply them, we get 10, and then the bottom one is still 7. Okay, now we're still looking for two numbers that multiply to the top number and add to the bottom number. So what would work? Now, on our last problems, we would just throw these in the parentheses and be done. Because we have an a value other than 1, we have an added step. Here's what that step is. You're going to draw the window, and we're going to work backwards to figure out what this started out as with those factors on the outside. So here's what we do know. We have 5 and 2. They go in these two boxes right here. It doesn't matter what order you put them in. And we always put whatever letter we have attached to them. Okay. Now along the diagonal here, we're going to put our original problem, okay, which is 2x squared, 7x, and 5. Okay, this is what we're going to do every time. We're going to practice this a bunch so that you see that the process never changes. Now all we have to do is figure out what is divisible, or what can we divide out of each column and row. So let's start by looking here. What could we divide out of those two terms, 5x and 5? We can divide a 5 out. Okay, so we put a 5 right there. What's in common with these two squares? A 2x. What's in common with this row? And what's in common with this row? Nothing? But there's always a 1 that we can divide out. Now what's on the outside here, what I just wrote in red, that's what your answer is. X plus 1, 2x plus 5. This skill of being able to factor is not going away. So please ask if you're lost on any of these. We're going to use this all year. All right, next one. So that one's done. Right here. What's the top number going to be? I got 72 by taking 6 times 12, and I got 17. What do we get? What two numbers? Is it 8 and 9?
Yeah.
That works, right? That multiplies to 72, adds to 17. So that goes in our window. In these two corners, the upper right, and again, it doesn't matter which order you put them in. You could put the 8 in the upper right and 9 in the lower left. It doesn't matter. The original problem goes along the diagonal, so 6x squared, 17x, and 12. And now we figure out what can we divide out of each column and row. So starting here, we can divide both of those by 3. What can we take out of this column? 2x. What about this row?
3x. And 4.
Okay, so here's our answer. 2x plus 3, 3x plus 4. Questions? Pretty straightforward. The process never changes. Okay? We're just going to get good at these so it comes quickly. Here we go. What's going to be the top one? Negative 12
Fine. I'm done with this. 1.
and 1. What two numbers work?
No, Charlie. -12 and 1. No, that doesn't work.
-3, 4. I heard a few people say it, but I wanted to make sure that you fully understood what was going on here. We need two numbers that multiply to be -12, and when you add them, you get the one on the bottom, which is 1. Okay? A few people weren't getting those right on the homework quiz yesterday, so I'm making sure that we fully understand. Okay, so we put these two numbers that we just found in these with the variable that's on our problem, which is not x anymore. This one's w. Put the original along the diagonal, and then we figure out what can we take out or what's in common with each of them.
-3.
So we got -3.
2W. W. 2.
Questions on that? So we've got w plus 2, 2w minus 3. Okay, this one.
20.
-20 and 7.
5 and no. 26 and no. 8 is 20. 10 and no. Should be right back in there.
Okay,
5
so
and 4. Negative. No.
okay, so other than William, hopefully the rest of you are going through all these options in your head. What options should you be thinking about?
5 and 4.
So that, okay, so that it's organized, we should start making a list. And we always start with 1 times,
Negative.
we'll forget about the negatives for now. So we got 1 times 20, 2 times, can we do 3?
No.
4 times, are there any others? So now we know for sure that this is what? Prime. Okay, none of those can give us 7 at all. So we've got prime.
Oh.
Always go through that list.
Wait for my head. Oh, shit.
All right, this one.
3. 4. Prime. 3 and 1. 3.
We're having an off day today. All right, so we put 3 and 1. Okay, or just write x. You can write 1x if you want to. The original along the diagonal. And then we take out what's in common.
Not 1.
So 1.
X. X. 3x. And 1.
So we've got 3x plus 1 and x plus 1. Questions on that? We need to get really good at this so that it takes really not a whole lot of effort except for finding the two numbers. The hardest part should be this step right here where you're finding the two numbers that work. When the numbers get a little bit bigger than 3 and 2, it does get a little bit tougher, but the rest of it should just be you drop the numbers in, you take out what's in common. Should not take very long. So this should be the hardest part. What do we get here?
Negative 1 and 3. No. Negative 3 and 1.
So now we have those two numbers and it unlocks the whole thing. So we've got negative 3x and x, the original along this diagonal, and then we take out what's in common.
Negative 1.
Here we have a negative 1, new color.
3x and 1.
Questions? We got one page left. Okay, these ones are a little bit bigger numbers.
36. Negative. I gotta do it first positive, then I negative.
Okay, so in your head, you should be starting to go through the factors of 36 and figuring out which one is going to give us 5 when we add them together.
3. -4. Positive 9.
Uh-huh.
3.
Again, we've just done the hardest part, is finding those two numbers. Here's the rest of it. Those numbers get dropped in, and the original goes here.
Do we have to put that number in the middle?
No, you do not have to put the number in the middle because you have figured out by now that we don't use it. That is totally fine. Okay, so right here, we can divide a -4 out of both of those.
3x.
We can take out a 3 and an x from both of those.
X.
The top row just has an x, and we have
3.
3 right there. The negative came out on the last column on the right-hand side, where they're both negative. Okay, so we've got 3x minus 4, x plus 3. Just a reminder that if you had your x plus 3 written in the front, it would totally be correct. There's no order to write those two parentheses. Okay? All right, let's try numbers that are even a little bit bigger. What do we get here? What's the top number?
120.
Negative?
Whatever.
Uh-huh. 20 and -6 works. Again, just start making your list. 1 times 120, 2 times 60, 3 times whatever, and get all of them up there, and you'll see the one that works. It also guarantees if something's prime if you get the whole list up there and none of them work. All right, so our 20 and our -6 go here. Original along here. If you want to write or skip writing that middle term, you certainly can. Okay, hold on. We're going to slow down a little bit just to make sure everyone's up to speed here. Okay, so all right, so looking here at this right-hand column, some new people volunteer their voices. What can we divide out of both of these? 4. What about this first column? 3t. And this first row? 5t. And -2. So we've got 5t minus 2, 3t plus 4. Questions? I'm going to give you a minute and a half to try these, and then I'll get the answers up there, about 90 seconds. All right. Looking at this first one, you probably figured out that if you multiply two negatives, we get a positive 30, which would also give us our answer at the bottom. Now there's a reason that I brought up these two types of questions. So let's go through this. What can we divide out of this? This? And here? Okay, now let's think about this. We have negatives on the 2 and the 15, but we need it to be a positive 6. They're both negative, here and here. If you would multiply these through, you'll notice you'll get a negative 15 because it's negative 3 times 5, and down here you'll get x times negative 2, which is negative 2x, but we still get a positive 6. So when you have negatives in the diagonals, but positive down here in the right, you know both of them are going to be negative. Okay, what about this one over here? What two numbers work? Now, there's a reason I brought this one up. Remember that we put the variables on that are in our problem, and it's always whatever you see on the middle term. Okay, so on this one we're putting AB on both of them. We have 7a squared. When we put these together, the corners, the 3ab and the 14ab, it combines to be this middle term. We have 6b squared in the lower corner. So we have to pay close attention. What can we take out of this last column on the right? What's in common? 3b. What about here? 7a here. Just a. And both of these negative?
Yes, sir.
Okay. So we've got a minus 2b, 7a minus 3b. Questions? The process is always the same, and the hardest part is finding these numbers right here, because everything else just drops into place.
Charlie, I can't do it.